Hello and welcome everyone to Multibiomics. Yeah, so this is like an introductory video for our project, which is titled AI driven tumor classification from histopathological images. So we are using deep convolutional neural networks, CNN. CNN is a deep learning model, and it's mostly used for when you want to train your model with images. So it is when you're working with images, you go for CNNs. Okay, and then we are using an architecture that is known as efficient net. So the domain that we are working over here is known as computational pathology because we are working with the histopathological images, right? So I have prepared this course for you, and in any point of time, if you believe or if you feel like the quality is not up to the mark, you can definitely give me a feedback. If you cannot understand any concept or if I am going a little bit faster, you can definitely message me. All of you will be having personal access to communicate with me. You can also message me on the Google groups. Okay, so next, what is this program? So this is a hands-on research grade computational pathology project, right? You will be coding, you will be doing all the work, I will be guiding you. So it is a research grade, definitely, because the baseline research has been done by me, but we'll be extending it. So I'm definitely hoping that you'll learn something from me, and you'll extend your horizon and you can give me some feedback, so what can be done to improvise this project more. Now, here you will be understanding what histopathology is, and then we'll train all those data sets. Those are images, and we'll be using deep learning models to train them. So, we hope that ultimately our work is accepted for publication, right? So we'll not be replicating anybody else's project, but whatever project that I have done already, so we'll be replicating that. And we'll be using two cancer research data set, that is one break that is breast cancer data set, and another one is UBC ocean, and that is for the ovarian cancer data set. Initially, for the learning purpose, we'll be implementing efficient net, which is the architecture for the CNN model, and we are using transfer learning. So we are not going to build with scratch, but first we will use a pre-trained model. Okay, so the pre-trained model will be used, and then whatever that model has learned already will be transferred into our image data set, and it will help in classification. So in this process you will learn what a convolutional neural network is, and maybe in future we'll switch to an upgraded version of the transfer learning, or we will make our own layers of convolutional neural network, and let's see what happens. So yeah, and we are hoping to produce a reproducible research, and it's very important. So people who are very new to the field of bioinformatics should understand what is a reproducible research. I'll not be discussing it right now, but yeah, I'll be telling about it. So you are a great fit if you're a student in biotech, bioinformatics, computer science, or life sciences. So right now we all are from life sciences, right? So it's a misconception among us life sciences students that learning programming and learning computer science is much tough, but no, this is vice versa. If you are a computer science student, there's much tougher to understand what is the biology behind it. Okay, so biology is a very deep subject, very deep subject. Every subject is deep, but biology is very deep. So the students from India, you must go through the CSIR net syllabus, and you should see how deep that syllabus goes, right? So whenever we are going to learn the biology behind our CNN model, our basics will help us to move further. And when it comes to code, we can learn it because nowadays there is AI and we can generate the code also, although you must know some fundamentals of coding. So yeah, you can see, so it's for students, researcher, professional, career changers. So whoever who is interested. So what is the prerequisites? You should know basic Pythons. Although there are few students who had asked me that they are interested in the project and they don't know about even the basic loops function libraries. Don't worry. Okay, I will be uploading some standalone videos in my YouTube channel. You can go through that. You can learn it for the first 10 days or 15 days. You won't be coding as early, but first we'll learn. So days are some days are enough. Few days, like if you dedicate 1 week, that's enough. So familiarity with Jupyter notebooks. I will tell you what is Jupyter notebooks. Most of you might know and some of you might not know, but it's just a interface where we'll be coding. That's it. Then you should have curiosity about biology and medicine. I hope every one of you has it. I do too. Now, if you don't have any experience in deep learning, I had some experience in machine learning earlier when I started this project, but I never had experience in deep learning, that too in CNN. So I started this project. I learned what is CNN, and then I got another chance. There's another project that I have done that involves graph neural networks. Okay, so if you practice, if you learn, if you do not confine yourself, if you're not afraid of trying new things, nothing is hard. It's not hard, but you have to give your 100% and definitely will crack through it, right? If you're thinking that you cannot code, if you cannot understand computer science, doesn't matter, we can try and we'll learn. So you should have a laptop with an internet access. High-end GPU is not needed, because I'll tell you how to, access Google Colab, or maybe we can work in Kaggle also. So I'll tell you about those interfaces later on. Now, so this is the program at a glance. 100 days, we have got 7 phases, we have got 2 data sets, 3 deliverables, like we'll be having code, we'll be having a model built, and if our research goes well and we all are stuck together for, about 1 year, so we can definitely publish, we can go for publishing our paper, right? So 1 year access you're having. So the 100 days 7 phases are not rigid, will be we can it is flexible, like it totally depends on what speed you want to go. Okay, so your 100-day roadmap, definitely I'm telling you, it's not so rigid, but overall, yes, total these 7 phases will be there. So these are the details here. Research foundation and data understanding. So here I'll be introducing you to the world of histopathology, and we will learn about the convolutional neural networks. We'll go through some basics. What is transfer learning in CNN or in any of the neural networks? What do you mean by transfer learning? Then we will go through some important papers, the baseline paper. So there's one session on that too. Then we will see later in phase 6 or 7, in phase 6, I guess. Yeah. So we'll be using some evaluation metrics. You will have a brief overview about your data set. You'll understand your data set, and which is very important. Again, I'm telling you, your data set is very important, because your work, even if you're going through other like genomics, transcriptomics, multiomics work, or if you're using deep learning AI, yes or no, whatever, understanding the data set is very important. Now, you will be able to define the research question. You will try to understand what this research is about. You will be designing the question. Okay, then you'll have a clear knowledge about what is the scope of this project, and you'll be also enriching your vocabulary for medical imaging. Next, the phase 2 will be downloading your data. So I have already uploaded these 2 data in my Kaggle account, but yeah, I will also tell you from where you get the original data set from. Okay, then I'll tell you how to arrange the folder structure. This is also, as a bioinformatician, it is very important to arrange your folder structure. Then these are some details which I'll let you later on, that how to because we are classifying. Okay, we'll be classifying into what kind of tumor this is. Okay, so class distribution is very important. Different types of cancer, how many images are there for each types of tumor? So we'll go through that also. And one of our data set deliberately we have chosen, that is breakhes, that has multiple magnification level. So I'll not go into detail now, but we'll see that. So here, so we have then phase 3 as data pre-processing. In data pre-processing, we'll be resizing the images. So what do you mean by resizing is that different architecture, the architecture that we are using here is efficient net B0. Okay. So it needs some particular size of image. Okay. It should not be bigger or smaller. So we'll resize all the images to an optimal size what the architecture wants. Then we'll normalize the data set. Normalization occurs everywhere, not only in bioinformatics but in data science. Your data must be normalized, so it's scaling the data. Suppose this data is this much small and another building is this tall. Okay, so you know you have 20 smaller buildings and suddenly you get one very tall building. So when you take the average, the very tall building can disbalance the average, it can shift the average towards itself. I hope you can understand the math. If not, don't worry, I'll be going deep into all these things, into all these topics. So yeah, normalization means scaling, and everything will be assigning as numbers. Even the images are fed as numbers to the computers because computers can only understand numbers, right? So what we'll be doing is all those numbers, even the images that are converted into numbers and fed into the model, will be in will be lying within the range of 0 and 1. So everything will be, so this is normalization. You're scaling everything relative to each other. So one any number should not be highly large and some number should not be very low. So when you take central tendencies like mean, median or something, you're averaging something. So your data should not be biased towards the higher number. So that is meant by normalization, where all the numbers value must be within 0 and 1. Okay, between that. Then we'll be training and validating and testing. Actually, we'll train that some of the data set. Okay, then we will test some data set and we'll validate it. And how to do that, what is the procedure, I'll just tell you when the class commences. Then we will go for label encoding and one hot encoding. I cannot tell you about it right now. You have to attend the classes, only then you will be able to understand. Then you have augmentation pipeline. So what is augmentation? Changes. You'll make some changes. So you will flip, rotate and zoom the images. Will be giving some flexibility. So a doctor can look at a picture at 90-degree rotation or 30-degree rotation. A human eye can still understand, oh, it's a tumor cell or non-tumor cell. If the eye is it doctor's eye is much trained, it can recognize those tumor patterns, right? So same thing we are doing this with the model. So we'll be augmenting the data, we'll highly enlarge or we will rotate it, we'll flip it. Even after that, our model must catch those patterns, the tumor patterns. And then some subtypes of cancer will have only 200 images, or maybe some subtypes of cancer might have 3,000 to 5,000 images. So this is class imbalance and we have to handle that. So all these things must be addressed, and I'll be teaching you that too. Okay, next we'll go on for model building and architecture setup. So here currently we are using, for training purpose we will be using the old methodology, but while implementing the new project we will definitely try to expand our horizon. Next we'll go for model training. And this is kind of a core phase, and you have to attend the classes to understand. And Then we will, after your model is built, you will evaluate your model, and it must give you certain output, certain pass, it must score certain numbers. So the score must be high. And what are those scores? That is accuracy, precision, recall, F1 score, confusion matrix, ROC, AUC curve. These all you should know how to study, and only if they are optimum, then only you can push your work to any publication house. Okay. So here we'll be doing misclassification studies. Yes, there will be misclassification even in very robust model as well. So you cannot avoid 100% any misclassification. There will be, but we are just aiming to reduce the amount of misclassification over here. Okay. And then very interesting will be how to plot beautiful visualization plots, graphs, to understand our output or our data. And we will be generating publication ready tables, evaluation reports. So I'm feeling excited about it. I hope you too. Then we'll have some discussions, and we will discuss. You'll tell me, I'll tell you about what is the impact of 40 magnification or 200x magnification, or what about the data set where all the images are, of same magnification. So, yeah. So, we will be discussing all these things, and we'll try to expand our, the radius of knowledge. Let us see. And then in the last phase, yes, we'll be indulging into writing our paper after the work is done. So, yeah, there are 7 phases, and there are 100 days of training, and then 1 year access of our work to be completed. But nothing is as rigid. We'll not move on to the next topic unless you are very clear with the previous one. Okay. So, yeah. So, what are the tools? So, there's Python libraries we'll be using. Definitely, we are coding in Python. So, the libraries are nothing but the collection of different functions and modules that we'll be using. So, for deep learning work, we need TensorFlow. You can see. For transfer learning, we are using efficient net architecture, and efficient net. For calling that, we need TensorFlow and Keras. Okay, for image processing, we want OpenCV plus PIL package. Scikit-learn for metrics, because scikit-learn is used for machine learning, simple machine learning, not for deep learning, but yeah, we'd need it. Then for beautiful plots, we'll be using Matplotlib, Seaborn. Okay. We'll be using Kaggle API for downloading our datasets. I would prefer you to code on Google Colab or Kaggle. Let us see whether we can get access to Google Colab Pro. If our work is going on smoothly, we will try to get an access to the Pro version for better GPU access. Okay. Then all the work that we are doing will be documented in GitHub. And so each one of you will get their own GitHub repository. Okay. And yeah, the 2 data sets are mentioned. So what skill you'll be gaining? The skills that you'll be gaining is medical imaging and histopathology, deep learning, how to evaluate any model, that analysis, research writing, making a reproducible machine learning pipeline, and your GitHub portfolio building. So these are the 3 final deliverables. Okay, so these are something which I've already told you. Why efficient net? Because we'll not be building CNN from scratch in the very beginning, because that will be much difficult for people who are new to CNN. So that's why we have used efficient net, but it is also very easy to handle by GPUs. So we'll be anyhow going deeply through this topic later on. So yeah, this is something what makes our program different. I would not boast about that my program is the best, or I'm just trying to be helpful, so I'll be putting some videos, some exercise, some data sets. Toy data set, not this time, because this is an image data set, but usually I help students first by uploading toy data sets if it's for any bioinformatics pipeline. Then later on, we go for the series data sets. But for this one, because it's an image data set, I cannot produce a toy data set. So this is something which multibiomics does, okay, every time. So let's not go through this. Yeah. So if you're ready, register now. You have already registered. This video is intended only for the registered student. And if someone who is not registered is watching, please, you have got time till 1st June. So I hope this was helpful for you to understand for our 100 days project. I will be interacting with you live, but also if you have any doubt, I will be preparing specially tailor-made video for you, and you can go through that. You can call, text me, you can email me, or you can message in the groups that I've created. I encourage you to talk in group rather than emailing me or sending me WhatsApp. But yeah, you can also tell me your problems during live sessions. Coding mostly will be restricted to live sessions only, not for a recorded video. Recorded videos are mostly for our theoretical knowledge, theoretical topics. So yeah, that's it. I hope you had some insight on what about our project is. So have a good day and see you on 1st of June. Thank you.